All right, so this is 6.5, composition of functions. So function notation is going to be written as f of x. And we don't say fx, we usually say it f of x. And if you've forgotten, just remember that f of x is actually equal to y. Do y'all recall that? Okay. So why did we replace y with f of x? Does anybody know? It's the opposite of x? Not quite.
I don't know.
That's it. So the reason why we replaced f of x with y is because it reminds us that we take x and we substitute it into the function. Exactly what Jackson said. All right. So why did we replace y with f of x? So input, output. Now, what does f of 1 mean then? Give you a hint. There you go, right? So if you think about it, this is really f of x. So what I'm telling you is that x is equal to 1. All right, so first off, we have f of 1. So right here, what I'm telling you is that x equals 1. So we're going to go to this graph right here. We go to x is equal to 1. Now, what I tend to do is I go down. Did I hit the graph? No. But if I go up, tell me when I hit the graph. Bam, right there. So if I know x is 1, I'm trying to find what's my y value. So what's my y value at this point? So we can say y equals 1 or f of 1 equals to 1. All right, let's do f of negative 6. So again, we're going to go to x is equal to negative 6. Go down, nothing. Go up, it hits right here. What's the y value? Okay. Now, why is the third one different? What's so different? So is that negative 3? Is it x or is it y?
It's Y.
It's y, right? So this time I'm trying to find x. So be careful because if it is a function, for every x value, there's only one y value. Do y'all agree? But if they give you a y value, there could be multiple x values because they never said the inverse is a function, right? So here, I go to y is equal to negative 3. And what I usually do is I draw a line through there just to see how many times it hits. But in this case, how many times did it hit the graph? Just once, right? So I go up to find the x value, and what do you think that x value is?
3.5.
So x equals 3.5. Any questions on that? All good? All right. Now this next part here, you're gonna have to fill out a couple of things. So let me kind of go through this with y'all. So this is called the composition of functions. So it says let f and g be functions of x. It says the composition of f with g is denoted by this symbol. F, a little tiny O that's in the air, G. And most people will say fog, but what does that actually mean? It means f of g of x.
That's like that little symbol that be on the scientific calculator.
That is it. So fog on scientific calculators, it actually means f of g. So it's a composition. So really what it is, it's like substitution. You take something, you substitute it into another function. That's all it is.
So if f of x is y and g of x is...
So f of x is usually original function, right? Or you can, really quickly, you can name it whatever. Like f of x, g of x, h of x, t of x, r of x, they all mean y. It's just people use different letters to represent different graphs. So like inverses, f of x is my original one, g of x is my inverse. So it's really just y equals, just one's the original, one's the inverse. So you can do whatever letter you want, but it's still going to be y.
G of x is still y.
F of g of x tells us that it's a composition, which means we plug one expression or one number into another function. That's all. So you plug one function into the other. All right. So the function fog is called, let me see, the composite function of f with g. So you start getting all this terminology, but once again, all you got to understand is that you're just taking one function and substituting it into another and simplifying or whatever it has you to do. So this is where it gets important. Oh, I forgot the E. Composite function. Now, No, if you are given an x, your answer will have a specific y. What that means there, if you take a number and you substitute it into a function, your answer should be a what? A number, right? If I plug a number into a function, so if I say f of x equals x plus 3, and I plug a 3 in there, what's 3 plus 3? 6, right? So I plug a number in, I get a number. If you're only given a function, the answer will be a new function. So if you take an expression and you substitute it in, your new answer will be a new expression. Okay. So if you get a number, you give a number, you get a number. You put in an expression, you get an expression back. All right. So let's see how this goes. Okay. So right here, example 4, it says let f of x equals 3x minus 14 and g of x equal x squared plus 5. What is the value of g of f of 4? Okay, so here's how I do these. So the first thing I'm going to do, I'm going to start with the inside. So you look where the number is located. If it's in the inside, you start from the inside and you work your way out. If it happens to equal a number, you start from the outside and you work your way back in. Okay, so in this case, we're going to start with f of 4. Bless you. Now, how do I know which function to plug 4 into? Well, what letter's right next to it? F, right? Because it says f of 4. So we're going to go to the f function, and we're going to substitute 4 into there. So we're going to do 3 times 4 minus 14. Does anybody know what 3 times 4 minus 14 is? Negative 2. So I now know that f of 4 is equal to negative 2. Now I'm going to show you this one time, and I probably won't do this part again, but the next part we usually do is we're looking actually for g of f of 4, right? But I now know that f of 4 is actually negative 2. So I'm actually looking for g of negative 2. So it took the place of f of 4. Now, Milan, where do I plug negative 2 into? The f function or the g function? And how do you know it's a g function? You are correct. Yeah, there's a g right there. So there's a g here. That means I have to use the g function. So we're going to substitute it in. Negative 2 in parentheses squared plus 5. So you'll notice every time I plug in the value, I always put parentheses around it. You need to get in that habit as well. So can somebody tell me what negative 2 squared plus 5 is? 9. Right, 9, right? So we have negative 2 squared is 4. 4 plus 5 is 9. So I'll accept the answer 9, but some people will put g of f of 4, and you just got to know that it equals 9. Questions? So that's what you get if you substitute a value into the function. You get another value. Example 5 is going to be a little bit different because we're going to plug an expression into an expression, so our answer should be some new function. Does anybody need more time or have any questions on this? The answer is just 9. So g of f of 4, it's actually equal to 9.
So is there going to be like any time where you can only have g of f of whatever the answer is?
Wait, say that again one more time.
Is there going to be any time where we where we have to? Because you say you accept this 9, but is there going to be like?
Oh no, the answer is 9. Yeah, no, that's good right there. Yeah. No, I mean, like I might write it like that, and you have just equals, and you put the 9. All right, so here's the composition of functions. Let f of x equal 4x and g of x equals 5x minus 2. Now let me ask you this. For example 5, look at these two expressions. Neither one is a constant, right? They're both actual expressions. So when you substitute it in, you will get an expression. So watch what I'm going to do. You really have to pay attention here. So first we're going to start with f of g of x. Well, this had a number before, right? But there was no number. Agreed? So I'm just going to do g of x. So g of x is right here. So instead of writing f of g of x, I'm going to write f of, and g of x is actually 5x minus 2. All right, so I want you to take a look at there, and let me know if you have any questions on what I just did. And if you're not sure, I'll tell you right now, all I did was I took 5x minus 2 and substituted in for g of x. Now before, like on the previous problem, take a look. I said f of 4, and I took 4 and plugged it in for x. Do y'all agree? So this time, this one says 4x, right? I'm not going to put 4 times some number. I'm going to put 4 times the expression. So these parentheses should match. So this was originally 4x. Now it's 4 times 5x minus 2. So you're actually substituting in for the x for the whole expression. Now, here you will have to simplify, and your answer should be an expression. Can somebody multiply this for me? What's 4 times 5x? 20x. What's 4 times negative 2? And can I simplify it any further?
Yeah.
Okay, what can I do?
Divide by 4.
Why would I divide by 4?
Because
It's not set equal to 0. So we're not solving it, right? So actually, this is your final answer. And that's why sometimes you might want to write f of g of x. That way so you don't divide by 4 by accident. Questions?
Would it be wrong to divide by 4?
Yes. In this instance, yes. Because that's the simplest form. If you're dividing by 4, you got to tell me where does 4 go. Because since you're not solving it, there's no really need to do that. Now, if it was a fraction and you could reduce it, sure. But at least I know where things are. Here, I wouldn't know where the 4 would go.
if you just
What
put
if-
20x.
Sorry again, go over it.
What if I just put 20x minus 8?
That's fine.
That's what I was-
Yeah, 20. Remember I told you 20x minus 8 is fine. I just added this here because when you start dividing by 4, that means you're thinking it's equal to 0. So just be careful. All right. For the second one, who can tell me how I should set that up? It says g of f of x. So how do you think I should set that up?
G of 4x.
Good. So all we're doing is we're literally taking f of x and changing it to what it is. In this case, it is 4x. So we're going to do g of 4x. Can somebody substitute 4x into the g function for me? If you want. 5 parentheses 4x, continue.
Minus 2.
That's it, right? So we change x to the 4x. Go for it.
Where does the x on the 5 go?
Well, you substituted in the whole 5x for the x. Like, think about this. The previous problem.
Oh,
This said 3x minus 14. Well, where did the x go? Well, we changed it to the 4. In this case here, we changed the x to actually 4x. So it replaces the whole thing.
So G is 5.
I'm not sure what that.
No, it says G of 4x.
Okay.
And the G is 5.
Oh, the g is 5x minus 2.
Okay.
So what we did was we took this 4x and we plugged it in
you
for
just
this x.
substitute in the X.
Exactly, just for the x only.
Oh, okay.
All right, can somebody distribute this for me? What do we get?
20x minus
20x minus 2. That's the answer I'm looking for. Again, if you want to put g of f of x, that is your call. Any questions? All right, so on your previous notes with inverses, I left this actually blank right here, and here's the reason why. So on your previous notes, you know how I said, how do you find if the inverse is a, if they're inverses or not? By compositions. Well, here's how you actually do it. So, so if you get two expressions, to prove that they're inverses, you actually have to do a composition twice to show that it simplifies to x. So you're going to do f of g of x. If that equals x, then you got to prove g of f of x equals x. And because they're both x, then it's a composition. So mathematically, that is the definition there. Now, I'll be honest with you, I've never come across a case where I do the first one and get x, and the second one's not x. I've never run across that. I'm assuming maybe it's possible, but me personally, I've never seen that. But let me go ahead and show you how you do this. So the first one says we're going to do this, f of g of x. And we'll see if it simplifies to x. Now, if it simplifies to x, you do have to show the other one. If it doesn't, it's pretty straightforward. It's not going to be. So instead of f of g of x, I'm going to do f of, what do I substitute in for g of x? One half x right here. G of x is 1/2 x minus 3. Okay. Questions? All right, now we're going to plug this into the f function. So the f function is right here. So how am I going to write this expression? Plus 6. Okay. All right, let's go ahead and distribute it. What is 2 times half of x?
Does it say plus or minus?
That's a minus sign right there. So 2 times 1/2 of x is 1x. 2 times negative 3 is negative 6. And the plus 6. Do I multiply the plus 6 by 2?
No.
Why not?
Because it's outside the parentheses.
It's outside the parentheses, right? So when it comes to this negative 6 and positive 6, they cancel, and it's just x. So right now, what we've just proven is f of g of x is equal to x. Now, So far, I would assume it's going to be an inverse because in order to be an inverse, they must both simplify to x. And the first one did, so the second one should. But let's just verify it. So I did f of g of x, so now I have to do g of f of x. So what are we going to change f of x to?
2x plus 6.
Good, right here. So f of x is actually 2x plus 6. We're going to change that parentheses to that. And now we're going to take 2x plus 6 and we're going to plug it into the g function. So the g function is 1/2 x minus 3. So how do I write that with 2x plus 6 substituted in?
Half parentheses 2x plus 6 minus 3.
There you go. Okay, so pretty much if you read it, look, 1/2 x minus 3, 1/2 this expression minus 3. Can somebody distribute the 1/2 for me? What's 1/2 times 2x?
X
X.
3 minus 3.
Plus 3 minus 3. What happens to the plus 3 minus 3? So g of f of x is also x. So since they both reduce to x, are these functions inverses? Yes or no? Yes, right. It's pretty easy. Yes, they are inverses. All right, so the way you tell they're inverses is when you do the composition, they must both simplify to x. Did they both simplify to x? Yes, so yes, they are inverses.
So instead of x, it gave you like 3x or 5x.
Okay, so if you get a number in front of x, like 2x, half x, 3x, not an inverse. It has to be x.
Okay.
Questions? All right, let's go to the next page. Oh, I'll leave it up there for a moment. And then we'll talk about the homework after this. All good? All right. I'm going to move on to the last page. All right, so this is just a little bit of practice of, so we know how to find the f of x equals something, right? Like f of 2, find the y value. F of x equals 3, find the x value. So now we're going to do a composition, which means we're going to do two of them at once. Just pay attention to the letters, okay? So f of g of 0, where do I begin? On the inside. So we start with g of 0, okay? Now look at your two graphs. Who can tell me which graph I should use? The second one. Why do you say the second one? Thank you. Who said it? It has a G. This has a G, G of X, right? Not anything else. It's because these are both G. That's why I know to use this graph. So 0, is that X or Y? X. So we're going to go to X is 0 right here. So I go down, does not hit the graph. When I go up, it hits the graph right here. What value is that? 2. So I know G of 0 equals 2. So this right here is no longer f of g of 0. It's actually f of what? 2. So now which graph do I go to? The first one, right? This one has an f. This one has an f. So that's what we're looking at now. So f of 2, I go to the x-axis, and actually it's already right there. So what's my y value here? It is 0. So my final answer is 0. You can put it there, or you can put it right, or sorry, you can put it right here. It's really up to you. But we now know the answer is 0. Questions on how I did that? How did I do that? Okay. So you agree it's g of 0. So I go to g of 0. 0 is right here on the g graph. I go up. It hits, what's the y value?
2.
So we now g of 0 is 2. So instead of saying f of g of 0, I changed g of 0 to the 2. So now I have f of 2. Go to f of 2. The y value for 2 is 0. So therefore, f of g of 0 is 0. All right, walk me through the second one. Where should I begin for the second one? The first one, and I'm looking for f of 1, right? So he said to start from the inside, and we're using the first equation because it's f. So can you tell me what f of 1 is? Okay, so let's go to f of 1. Is this x or y? Let's start there. That's x. So tell me to stop when I hit the graph. What's the y value? 3. So f of 1 is equal to 3. Now instead of saying g of f of 1, I'm going to say g of what? 3, right? Because we now know that f of 1 is actually 3, so g of 3. So which graph do I go to now, the first or the second? Second one. And I go to x is equal to 3. 1, 2, 3. I go down. I don't hit the graph. I go up. What's the y value when I hit the graph? 1. So there's my answer, or you can put it up here. So g of f of 1 is equal to 1. Questions? Now, believe it or not, the last one you really have to pay attention to. First off, that number 3, is that an x or a y value? It is a y value. Now, is that inside or outside? So we start from the outside. So I'm going to actually change this to f of x equals 3. Which in essence really reads at y equals 3. Do y'all agree? Y equals 3. So I'm going to go to the f graph, and I'm going to draw a line, a horizontal line, through the value of 3 on the y-axis. So here we go. Here's 3. I'm going to draw a line through there. How many times did it hit the graph? It hit it twice, actually. The first one, it appears to be right here at x equals 1. The second one is at x equals 5. Now watch what I'm going to do. Was this right here x to begin with? What was that originally? It was g of x. So it's not actually an x. Hopefully y'all agree it is g of x. So what actually happens is we have g of x equals 1, and g of x also equals what? 5. So when I go to the g graph, how many horizontal lines should I draw through it? 2. The first one is going to be at y is equal to 1. The second one will be at y equals 5. So let's start with the first one. These are going to be my solutions now. So for the first one, it hit at x equals what? Negative 1, positive 1, and 3. Negative 1, positive 1, and 3. Now I'm going to look at the second line to see if it hit the graph at all. Did the second line hit the graph at all?
No.
So there are no solutions from there. These are my 3 solutions. Questions?
If it's like a,
Right after the commas.
Yeah, x equals, yeah, you can use braces. I just put that with the commas.
if it like goes over a point that's not marked.
Like with an open circle?
That, like if it was y, like if it was y equals 0 instead, where it goes over that one point, but also
The 2?
the unmarked area.
So you're talking about like if it went like right here.
Yeah.
So it would have 2 solutions. It would have this point here and that point there.
How would you find where that point is though?
Estimation.
So just negative 1.5.
Yeah, I would accept negative 1.5.
Points are just there to show you.
Yeah, I mean, the points are there because I knew that's where I wanted the solutions to be. But on a quiz, I know we give decimal answers. So as long as you round it at least close to where it should be, I would accept that. Usually we go in quarters. All right, last problem for the notes. Then I'll talk to you about the homework. Okay, iterations. So let's talk about iterations. It says find the next 4 iterations of each function given the initial value. So these are actually pretty cool to do. They're easy. If you catch the pattern, you can do it like in 2 seconds. If you don't catch the pattern, take you about 2 minutes. But let's see if y'all can catch it. So the first one, it says given the value. So the first thing we're given is that f of 0 equals 4. Everybody good with that? So we're going to start with f of 1 because my first one is f of 1. So pay attention because this is not too hard. So what we're doing is 1 is taking the place of n. Do y'all agree? Okay. So now I'm going to write this function f of, what do I change this n to? 1. So f of 1 minus 1, close the parentheses, minus 5. Let me know if you get confused. If you do, say something, but if not, I'm going to continue. Is everybody okay with what I've done so far? What's 1 minus 1?
0.
So now we have f of 0 minus 5. All good? Well, here's where you got to understand. We know what f of 0 is. Who can tell me what the value of f of 0 is? 4. How'd you get that? Because right here, f of 0 equals 4. So what we're actually going to do is we're going to change this to 4 minus 5. And what's 4 minus 5? So my first answer is -1. Any questions on that? Now, by the time I finish the second one, somebody will know the answers to f of 3 and f of 4. It always happens. So pay attention. So now we're going to do f of 2. This one I'm going to do in a straight line because I just showed you the work here. So I'm going to take the function again. F of 2 minus 1 minus 5. So take a look. Let me know if you have any questions on what I just wrote there. So all I did was plug the 2 in for the n in the original equation. What's 2 minus 1? So would you agree we have f of 1 minus 5? So what's f of 1? Right here. F of 1 equals what? So instead of writing this, I'm going to say -1 minus 5, which is -6. I'm curious. Without doing any math, does anybody know f of 3? -11. And what's f of 4? Bam, there you go. Because it's not just a pattern, it's actually a formula. So let me show you the understanding. So we understand, and this is why iterations are cool. N is currently it, right? N is the current one. When you see f of n minus 1, that means the previous term. So f of n minus 1 means the previous term. So the previous term to -1 was 4. Do y'all agree? The previous term to -6 is -1, the previous term here, and so on. So what this tells me is take the previous term minus 5. So what's 4 minus 5? -1. For the next one, the previous term is -1. What's -1 minus 5? -6. For the next one, take the previous term. -6 minus 5 is -11. -11 minus 5 is -16. So it's a pattern. So once you catch it, you can actually just jump straight to the answer. So like Ben just answered that. Do you think I'm going to expect to see work for f of 3 and f of 4? No, because it's an understanding of the concept. All right, and that's going to conclude the notes. Let's talk about the homework next.